Slides, yes.
Yep, we can do slides.
Good. Well, cool. All right. Well, welcome everyone again. My name is Liana. I'm going to host tonight's session just to kick us off and just give you a little intro about what we're about for those that are new. Today we're going to be exploring Kaggle's Mini Courses. Some of you might be familiar with this. And I believe, George, you're going to be taking this. And we're going to be doing some Python, intro to Python stuff. Give you a little background of how it came to be, where you can find us. Most of you probably found us through meetup.com. So, and if not, we are under Deep Learning Adventures on meetup.com. So check us out there for all upcoming events and details. But I also want to point you to the GitHub repo and Slack channel for Deep Learning Adventures. That's how you can really participate, participate through the sessions and the community in general. Our organizers, coordinators of this event post their repos to GitHub, so you can follow along to not only future and current, but also past things that we've done. And finally, YouTube. All of the past sessions are recorded. This one's being recorded right now. So if you want to see what we've done in the past, jump onto the YouTube channel. You can see coding challenges that we've done, as well as speakers that we've had in the past. And then I believe, looks like we've got another course for this Kaggle mini series. Alrighty, moving along. In the past, we've worked with TensorFlow. We won't be working with TensorFlow today, but just to give you a background, that is what we have done in the past with some of the projects. And typically, we're working in Jupyter Colab. So it's a really good interactive platform. If you haven't used it already, I encourage you to look it up. Very similar to just your local Jupyter notebook. So just some past things that we've done. We've done classification problems.
These are called
NLP problems. Sorry, my husband's on a call. It explored some really fun data sets like the Friends, Big Bang Theory, credit card fraud detection, which is a good one for if you want to get experience with anomaly detection and imbalanced data set. This was quite an imbalanced data set. And then time series predictions with some weather data. So I encourage you to look at some of those past ones that we have done as a group. I believe today we're going to be breaking out into small groups. Are we still doing that, George? Doing small group breakouts?
No, I think we're just going to welcome people. And I see some faces, so if you don't mind unmuting yourself, just introducing yourself and where you're joining us from, that'd be great. Let's see. Gonzalo, I think you told us you joined us from. Okay, Christian from DC, Gonzalo from Seattle, Washington. Casey, welcome. Not sure where you're joining us from. Want to make sure you feel welcomed.
On Slack, there's a welcome channel, so feel free to say hello and tell us about yourself, where you come from. I also just want to make note of masterminds behind the meetup, which is David Patton, Robert Cragen, Zoto. They lead a lot of our sessions, put together notebooks, and provide a really cool experience. So reach out to them for any help. I'm dobbing you in for that one. And yeah, I guess we can get started. Again, today, this is the mini series. One really great thing about this group, it is really collaborative. And I know George has spoken about wanting it to be more inclusive. So please do volunteer if you want to lead a session on a topic. Doesn't have to necessarily be the mini series. If you have other ideas for topics that you want touched on, or if you have something that you specialize in that you want to share, reach out to George or David or Robert. I know they'd love to hear it. But I will hand over to George to start the mini series. Last thing that I'll say is to everyone just take a moment to check if you are on mute. Please keep yourself muted throughout the session, unless you have something to chime in on. So unmute yourself and ask a question, of course, but other than that, everyone just check right now that you are on mute. Cool. Hand it over to George.
Cool. Thank you, Lana. Thank you. Thank you very much. Welcome, everyone. If you're new to our meetup, again, welcome. We're welcome. If you see me looking around, it's because I'm admitting people on our session. Yeah, my name is George, and I'm joined today by my great friends. Thank you, Lana. My great co-organizers, David, Robert, as well as our informal co-organizer, Dimitri. We'll be talking a little bit about Python today, and really love to get some feedback from you, friends, towards the end of how much time do you think we should spend on the theory part versus the exercise. As you'll see, each course has a tutorial part as well as an exercise part. As well as there's about 15 or 16 courses. We'll have to get some feedback in the end towards, we can pick and choose some of them. Maybe we can do the machine learning and deep learning part, or if we want, we can maybe quickly overview all of them. So keep those questions in mind, and maybe towards the end I can ask you for some feedback. That'd be awesome. Cool. With that said, let me share my screen. Can you see my browser?
Yes.
Perfect. Thank you. Awesome. So as Liana mentioned, today we're going to tackle Kaggle's mini courses. And if you're not familiar with Kaggle, it's basically a data science platform. It was acquired by Google a year ago or a couple years ago. It's a great place for you to experiment with different data science notebooks, comment on other people's code, as well as join competitions. Kaggle is known for their competitions. Some of them have interesting awards as well, and great causes behind them. So check it out if you haven't never heard of them. Otherwise, if you're familiar with Kaggle, they have a module called Courses, and that's what we're going to tackle today, especially the first course on Python. And as I mentioned earlier, there's about 15 of them. So take a look this week and think about what are interesting to you, and what things would you like to maybe take a deeper dive. Of course, on your own you can do all of them, but as a community, we always find it more motivating and more challenging if we do it as a group and we talk about the code and the theory as well. Okay, 2 more people admitting. So for the Python course, there's about 7 quick sessions. I'll be covering the first 3, and David 4 or 5, and Dimitri 6, and I'll be taking the 7th one. So with that said, there's not a lot of slides. We'd rather spend some time on the theory part as well as the exercises than put together content. So I'm gonna zoom in a little bit so you can better see my screen. I'll quickly go over some of the tutorials, but really I want to spend some more time on the exercises. Again, if you're new to programming or if you're new to Python, it's a very user-friendly language. It's known for its extensive use on data science, along with R, for many of you who might know R. It's very easy. Compared to other languages, you don't have to declare the data types for a variable. You don't have to declare the things before you use them. You can reassign variables. So for example, here we have just a simple variable, spam amount. It's equal to 0. We can add to it. We can do conditionals like if statements, if you've seen them from other programming languages. And the interesting thing about Python is you can use variables without defining them in advance. They'll be defined as the program is run. And you can even change their data type. So it could be an integer right now, but later on it could be something else. It could be a list, for example, as you'll see later. It could be character, it could be a string, or it could be dictionary, as we'll see later on. Cool. So yeah, that more or less what I was saying before. Comment, hashtag is a comment in Python. Let's see, I'm just trying to pick up some interesting features that are either different or unique to Python. So for example, if you've seen the multiplication operator in other languages, so this probably won't make sense in other languages. You have a string spam and a star or add or times a spam amount, which is an integer. So in Python, that actually means repeat. So here we're using this operator to actually repeat the string 4 times, which is spam space 4 times. If you want to look at the type of a variable, this is where useful command type will give you the type. It could be int, integer, it could be a float, a decimal, and it could be something else, as you'll see. It could be an object, which is a generic Python object, or list, as we'll see soon. And in terms of basic operators, they have the classic ones from most programming languages: addition, subtraction, multiplication, division. Python has a // which is for floor division, which is basically removing any fractional parts. So as you'll see here, 5 divided by 2 is 2.5. But if you do 5//2, it's just the 2 part with ignoring the decimal part. So that's the difference. The order of operations is useful. It's highly recommended that you use parentheses whenever you're in doubt, but in terms of order, the parentheses are executed first, then exponents, and exponents in Python are ***, as you'll see them, then multiplication or division, then addition or subtraction. So in this expression, for example, the multiplication will happen first, 4 times 2, then the addition plus -3. So that will be the result 5. And again, highly encouraged to use parentheses because they make your code unambiguous and easier to troubleshoot. In terms of functions, functions are basically pieces of code that have been written by the Python developers. Some of them are built in with Python itself. You don't have to install anything. Some of them you have to actually install. You might have to install them, and some of them might already come with Python, but you have to what is called import them in your code. So the classical ones like min, max, you don't have to import them. They're already imported by default. And if you give what is called a tuple or a collection of numbers here, you're just going to pick the minimum or the maximum of them. Abs stands for absolute value. This is another built-in function. What are called the constructors, sort of, if you've heard of that term from like from an OOP programming language, object-oriented. If you want to convert something to float or integer, you can do that with calling the float function and giving the number as an argument, as an input. You could even convert characters to numbers and then add them up. Cool. I can quickly go over the exercise, but now would be a good time if you have any questions. Feel free to write them on the chat or unmute yourself. It's very basic so far. Cool. So let's take a look at the coding exercise. So if you notice, the link there is a URL that basically forks or copies another notebook. And this notebook runs on Kaggle, which is a hosted environment. You don't have to run it on your computer or anything. It's running on Kaggle's infrastructure. And it will actually be tied up to your profile. So you can save different versions, you can share it with others, you can make it private or public. And if you use Colab, it's a little bit similar to Colab. You can see how much CPU you have, how much RAM you have, and how much space you have. Cool. So with that said, this is again like a Jupyter Notebook or Colab if you've seen it. You have different sessions here. You can do Shift Enter to execute them. And you basically have the option to create a code cell, which is exactly what it sounds, a code cell. Or you can do what is called a markdown, which allows you to basically document your code. So a combination of both is highly encouraged so that you can both document your code as well as write efficient code as you go by. Usually these exercises have what is called an session here that allows you to import some modules from Kaggle. Those are helpful because they allow you to not only score your exercises, but also get hints or even the solutions in case you're stuck somewhere. So the first thing you do is just import this session and then keep going on. I won't be going through all of them. I'm just going to go through some of them that I found interesting. If you're interested in finding out what is called the attributes or the different functions that a Python object offers and has under the hood, again, we haven't talked about objects much, but think of it as a collection of data and data structures that Python uses under the hood. So if you want to see what can you do with a Python object, if you call the __ method, usually these are built-in methods, the __ something __. These are built in with a given object or class. So you'll see a lot of options here. Some of them are easy to read, some of them you might need some more information on. And the way that a library that I use, and maybe this is skipping ahead, but I was trying to get an idea of how do I see the hint, where is it defined and all that. So there's a module in Python called inspect, and you can get the source code for a given object or a given method. You can also see where it is defined in your library, and you can see what does that function do. I was basically trying to reverse engineer what does this hint and solution do in Kaggle code, but it's outside the scope of this exercise, so you can ignore it. If you're stuck somewhere, you can just do a hint or to get an idea. And if you're really stuck, you can do a solution. But I highly encourage you to try it on your own first, whatever the exercise is, before you look at the hint or the solution. Cool. Then this exercise goes more onto some of the operations, the multiplication, division, and all that. I won't go through all of them. The floor division. This emoji here means that's a little bit tricky, and you have to spend a little bit more time. And this was just a fun exercise of. You'll see towards the end some exercises are really well thought and fun to run. Cool. I want to give some more time to the other courses and the other modules. So any questions or comments about this very first module on syntax, variables, and numbers? Chat, or feel free to unmute yourself. Okay. If not, let's take a deeper dive on functions and getting help. Python has this built-in function called help. So if you're not sure what a method does or what a function does, you can do help and that's the name of the function. If you come from like a Linux or Bash background, it's similar to doing like a man page for that class. It's basically the documentation for that class. So in this case, by running help round, you get to see how this function is called, what does it return, and some description on what does it do. So in this case, it's returning a number, and it takes an input, which is number of decimal digits for precision. Going before, remember to give the name of the module, not calling the function itself. And that will give you help on what is returned by this class, which is in this case a number. Print is a very heavily used function, so you can look at that as well. You can also define your own functions, and the way you do that in Python is use the keyword def, define, the name of the function, and then in parentheses, how many arguments your function can take. You can take as many as you want. And you don't have to specify the data types of this argument, so it could be anything. And here you can do something, let's say you're trying to figure out the differences among different variables, and you're trying to return what is the minimum difference between A and B, A and C, and B and C. That's what you're trying to do. And the return is a special keyword in Python that basically exits the function and returns whatever value you have here on this expression. You can call this function as many times as you want. In this case, we're calling it 3 times. So what is the least difference between 1, 10, and 100? It's 9. It's the difference between 1 and 10. Similar for the other ones. If you call help on listIf on the function we just created, you're not going to see much, just the basic name of the function and the arguments. You can use something called Docstring in Python, which is basically a nice documentation, a quick documentation for your class. In this case, you have a description. Highly recommended to also include an example so that now when you call help and your function name, you basically are getting this expression here. And in case you haven't seen this triple quotes before, that means that you can do multi-line comments in Python. So if you want single line, you can do the hashtag. Otherwise, if you have multiple lines, you can do the triple quote. And in Python, I don't know if I mentioned this, single quote or double quote is exactly the same. There's no difference. So you can define anything with either single quote or double quote. as long as you don't use that character as part of the string itself. You can have functions that don't return. Maybe they do something, but they don't return. Maybe there's something in the back end. You can have what is called default arguments. Basically, if an argument is not specified, you can specify it by default here. It will use that. And the other thing is you can call functions within functions. So for example, here we have a function called multiply by 5. You have another function called call that takes a function as an input. You can't really tell it from the variable name, but basically calls that function with that argument. And what you're doing here is you're calling, so you're calling multiply by 5 and you're giving as argument 1. That will return 5 times 1. And then when you call this squared called, it will call the function 5 times 1, 5. Then it will call the same function with the output of the first function. It's like a nested call, basically. So that will be 5 times 5 times 1, just 25. I think that's about it. Let's quickly look at the notebook. I think it's more or less what we covered in the tutorial part. Let's quickly take a look. Yeah, we're called to create a function that does rounding for 2 decimal places. Another one. Yeah, more or less what we saw before, so nothing new here. Any questions about functions and getting help and how to navigate yourself within a Python environment? Yeah, thank you, David and Robert, for monitoring the chat. I'm not monitoring that, so please let me know if there's something there. Cool. Okay, let me quickly go over number 3 before I hand it over to David. Booleans. So Boolean is actually a data type in Python. It can only contain 2 possible values, true or false. So in this case, x is equal to true. You're printing it out and it's true. What is the class? It's a Boolean. And you find out the class by using the type built-in function. Some comparison operators here. Equals equals is the operator you'd use if you want to compare the value of A and B. Less than or equal, greater than, not equal, greater than or equal. Let's see. If you try to do a character equal a number, there are different data types. So by default, Python will return false here. You can build your own function. And if you see the function is returning a comparison of something on the left hand versus something on the right hand. So in this case, you're dividing something by 2 and you're trying to see if this is odd or not. And if there's a remainder, when you divide it by 2, that remainder is 1, then it's odd. So 100 is odd, is false. -1 is odd, is true. You can combine Boolean variables with special keywords or operators and, or not. It's like Boolean logic, so true and true is true, true and false is false, and you can create those tables for the other operators as well, or and. Not a good idea to leave everything without parentheses because it's hard to figure out what is the order here. So for example, this expression, you're trying to figure out if you're prepared for weather. So you have a variable, if you have an umbrella, or if the rain level is less than 5, and you have a hood, or it's not raining and it's not a work day, it's very hard to read. So it's highly encouraged that you use parentheses to make your code unambiguous and really allow Python to execute the nested parentheses first and then the entire expression. This entire one-liner could be written into multiple lines if that's easier for you to understand as well as for other people to read it. So you can do that as well. Cool. Conditionals in Python are basically constructions that allow you to control the flow of your program. And by that, I mean, you can navigate the flow to a specific branch of your code based on some conditions. In this example, you have a class, you have a function that accepts an argument x. You're checking if that argument is equal to 0. If so, you print this value and you exit this whole statement, and there's nothing in the end. So you're actually exiting the entire function. If it's positive, you return this message here. If it's negative, you return this message here. Otherwise, by default, if it's something else, I'm not sure when this will be done, we return this value here. So when you call it inspect 0, it will match this part of the function here. Indentation, I didn't mention this, but indentation is key to Python. Many languages have curly brackets, but in Python, you heavily rely on the indentation to basically distinguish when something is inside a code block or not. So by default, anything here that's indented, it's part of this function. Not only that, but something here that's twice indented, it's part of this first indented line. So these two print statements are actually part of this if statement. And this last statement will always be printed because it's a last statement of the function. So no matter what you call this function with, you're always going to see this always printed regardless of x's value. But these two statements here, you're only going to see them if x is positive. Great. Another thing you can do is remember you saw float and int as functions you can convert things into. You can also convert things into Booleans. So 1 will be converted to true, and 0 will be converted to false. Any character will be converted to true, and the empty string will be converted to false. Cool. Let's check out the coding problem if there's something there that was different in theory real quick. Function to create the sign of an argument. This one where you have to spend some time on, so the goal here was without using parentheses, can you find a bug? And there was a bug here where for some combinations of your variables, you're getting unexpected results. So the whole point was that please use parentheses so that your code is unambiguous. Negative, something about toppings and orders and Boolean values. I highly encourage you to check them out. And the blackjack was interesting to me, so I'm curious if anybody tried it. But I posted a question on the forum. Kaggle has a forum of if anybody got a better number, but I think I got about 40% win rate here. You're playing blackjack on 50,000 simulated games, and what are some strategies that you tried, and what is your win rate versus the house? Cool. Let me check how we're doing with time. Good. I think that's it on my end for 1, 2, and 3. If there are no questions, I'll hand it over to David to go over lists and list comprehensions.
Can you see Python lists?
Yes.
Did you see it?
Yep.
Okay,
Yes.
great. So I've taken a slightly different approach here. Just going to, instead of going through the Python course, I went ahead and basically for the list and this section, they just are showing examples of code and then talking through it a little bit. So I thought I would take a risk here and show it in real time to you. So the first part, we're talking about what is a list. If you're familiar with other languages and collections, list is a very common type of collection in programming. In Python, it's basically an ordered sequence of values. And I've got a couple examples here of numbers and names where the names are strings. And one thing to note about the strings here is that you can have a a comma at the end. Python's comfortable with that in a list. It just ignores it, as you'll see when I print out these values. So there's my numbers and my names, and it just ignores that last comma. You may also put different kinds of things into a list. So different types of objects, strings, the results of other function calls, floats and integers can be mixed. So all different types can be mixed. You notice here I'm putting a list. Where's the sharing? Sorry, I'm just trying to look for my. Okay. Sorry, so you'll notice here in here I've got a list with additional list inside as some of the types. And for example, in the second list in there, I've mixed in strings and numbers together. So it's AZ or strings, and then 2 is a number. And that's fully allowed. If we print those out, you'll see that the result of max, which is a function, built-in function that George mentioned earlier, pulls out 9 for that position there. Lists have the ability for you to retrieve and view certain objects via an indexing system. Many other languages do this, and it's always a question of what does the index start with, and they're integer based. And in Python, we start with 0. So the first element in a list is indexed by 0. Again, looking at our values up there, if I pull the first index or the first value, we'll see that it's not the list that says 1, 2, 3, it's the list that starts with AZ and has 2. Within that list, I can then get another index of the list that's inside of a list. For instance, here, this should give me the string A. So I pulled out the second list and then the first entry in that list. We can also do things like put negative numbers in here, and in this case, it's going to pull from the end of the list the second value. If I had -1, I would have got 4.6, but here I get 5.3 when I use -2. There's also the concept of what we call list slicing, and I'm going to show, just reprint out the numbers list again so we can see what we can do. So here I'm going to do start with index 0, and then the colon tells me I'm going to go to the next part of the slice, which is I'm going to end at index 2. And if we just really quickly print out that, we'll see that that gives us the first item, which is 0. It also gives us the next index, which is 1. And we stop at 2. We don't actually get the value for the last, for 2. That's our stopping point. So everything up until 2. We can also do something like this, where we're doing -2 in the first part of the slice, which tells us to go from the, starting at the end, we're going to go 2 back to 4. And then we don't put a value for the stopping point. That just says go to the end of the list. So here we get 4 and 5. If we do 4 and then go to the end, we can get the same result. If we were to go from the start, because we don't put a value in front of the colon, so all the way at the start of the list to -2, this will give us the 0, 1, 2, 3. And notice we don't get the -2 because it's at the end. Lists have a property in the sense that they're mutable, which means that you can on the fly change values within the list. In this case, I think our third row here was the value 3. Sorry, the third index is the value 3, which is actually the 4th position. I'm going to reset that to 100, and then I'm going to print it out, and you can see that it did make the change within the list. So that's an easy way to make changes to a single index in a list. And you can think of different ways to do that. Lists have a bunch of built-in functions that you can use against them. They're very similar to all the other functions, but how do they work on a list? So again, we've got our numbers up there, 0, 1, 2, 100, 4, and 5. So that's got how many entries in our list is what len is. We're also going to run sum, where it's going to count up all the values and add them together. We can put them in order, which is sorted, and we can calculate what the minimum number is inside of the list. So let's run those. So we can see we've got six values in our list. 112 is when we add every number together. These happen to be integers, so it's going to come up to 112. And then when we sort them in order, the 100 goes at the end as we expected. The minimum value in our list is 0. Now, one thing I would show you real quick is that if we print out numbers again, we can see that it's not sorted. We haven't actually done anything because all of those functions output values. If we wanted to have our numbers be sorted, we would have had to reassign it to the output of the sorted command or function. And here I just printed out, they don't have this in the Kaggle tutorial or the course, but I put this out there. These are the built-in methods that are available that you can run on the list. And if you look closely at the descriptions, you can tell that some of them, like we're going to go through append in a second, it does something to the list, but something like copy returns a value. So it returns an actual copy of the list. So you would want to set that to a new variable. Count, for instance, you want to set that to a variable. It's returning something, right? Where something like insert is going to make a change to the list, but it's not returning something. So that's just something to be aware of. And I'm going to show some examples in a second. So the first one I'm going to do, they went through it in the tutorial a little bit, is append. And append is a nice function that, if we read up here, adds an element to the end of our list. So anytime we want to, add more values onto our list, I will tell you, we'll go through some of this in more detail. But here I'm going to print our numbers. We had, just to refresh our values we had, and then I'm going to print out the result of doing the append. Why does that give me none? It's because there's no result that comes from this. So I'm just printing the result of the function. But if I print out numbers now, I will see that I did actually change the list. I added 56 at the end. There's another function that they don't go through in the thing, but I find very useful, which is called extend. And it's very important to know the difference between appending and extend. Extend allows you to add a list or any other iterable, basically, to the end of the current list. So it's a really nice way to add more than just one entry at a time. If you have another list and you want to basically concat them together or extend them, you can do it this way. So here I'm going to create a new list called new numbers, and they're all going to be negative. And my original numbers, which are up above, I'm going to extend my list, and hopefully you see that it prints none, but if I look at the actual output, it's going to add them to the end as we expected. Now in this case, I'm going to do something where I call clear, which removes all the elements from the list. And I'm going to extend my list. My list still exists even though I removed all the list. It's called an empty list. And I'm going to extend it by adding another list to it, and we should see that. And now my new list just has the new ones that I added. You can actually use the plus symbol to do concatenation. So for instance, here I'm going to add another list called 3, 4 to here. And you can see now I didn't actually, the difference here is when I use extend, I didn't have to assign it to anything. But when I do numbers plus 3, 4, it output the result. So this is as if I printed out the result of that operation, but it didn't actually change my original list, right? So my original list still stayed at 1, 2, 3. If I wanted to change my original list, I would have had to assign it, which is what I'm going to show here. And now I get it as a full list with all the values. I mentioned the empty list. That's a useful thing to use. Basically, you're declaring a list with no values in it. You can see that when I print the length of it, it's 0 in length. And I'll show some examples later on of how you might use that. Besides lists, there's another type of collection. George mentioned it briefly in his earlier code called tuples. So a tuple is very much like a list except for two differences. One is that when you declare a list, you're using so the square brackets, and when you do tuples, you're using parentheses. So that's one big difference. And here's a tuple of a string, Google, and 5. Tuples are immutable, whereas before in a list, we could, by putting the index, we could have done something like this and just set the value to a new value. If I try that with a tuple, I'm going to get an error. Just for fun, they didn't do this in the Kaggle thing, but I wanted to show you how you could cast something. So I'm going to take that tuple, cast it as a list. So now you can see it has square brackets. It's no longer the parentheses. So now I have a list. I'm going to now do the, because lists are mutable, I'm going to do the assignment. And I'm going to recast that list back as a tuple and print it out. And you can see I actually made the change. So it's just playing around for fun there. So that, I think, takes care of that section of list. Are there any questions about lists? I haven't checked the chat, but hopefully George or Robert are looking at that. Okay, I'll move on to part 4 of the course, which involves loops and list comprehension. So George introduced, I think, a few things with regard to indentation and why that's important. I'm going to first declare a list of numbers, it's things. The only thing I require here for loops is that this be something that's iterable, that I can go through one at a time. In this case, I'm using a list because that's what we just learned about. And I'm going to do a for loop. A for loop is going to allow me to go through each value in my list of things and do something with it inside that for loop. I could do, a whole bunch of calculations, call their functions, do mathematical calculations. Here, I'm just going to print out the values, and you can see I'm going one at a time and printing on each line the values that are in my list. I could have done this with another type of function called a range function, which would also produce a iterable list of numbers, and it actually, because I put 5 in there, it's going to produce the same output. Range, I was just trying to show here, range has some arguments to it. The start, the stop, which is what the default one I put in there is 5, and the step size. Here's an example where I'm doing a for loop. I'm going to start at 3. I'm going to stop when I get to 8. And I'm going to go 2 steps, 2 at a time. So I'm iterating through 2 at a time. So here I'll get 3, which is what I started with. I'm going to go a step of 2, which is going to be 5. Print that out, give me another step of 2, 7. And I don't go to 8 because if I step again, I go past that. So I reach my stopping point at 7. Any questions on for loops? Very, very commonly used control flow in Python. The next type of loop I'll just introduce real quick is a while loop. I'm going to use a random number generator. I don't want to go into too much detail. This is an external library, maybe something that you'll learn a lot more about when Dimitri talks about external libraries and things. But it's built in, but you have to import it. And remember I mentioned that we can define an empty list. And the reason I'm going to create an empty list here is inside of this loop, I'm going to append random numbers to it, okay? And as opposed to a for loop, I need to have a Boolean expression for evaluation here. And anytime that, while that Boolean expression is true, I'm going to loop through whatever's in below here that's has the indentation. So over here, I'm going to loop through whenever the length of the numbers, which is this array, or sorry, this list I'm adding to, is less than 10. So as long as that length of that list is less than 10, I'm going to append a new value to it, a new random number between 1 and 100. So this kind of covers a couple of things that we've talked about with empty list, running functions against the list, and then how we do that append to it. Remember that append, we don't have to reassign it, makes the change to the list directly. So let's go ahead and run that and see what we get. So we should get it now. We have a random numbers between 1 and 100, which are in a list that is 10, a length of 10. And that's kind of what you can do with a while loop. There's more advanced things, but this is pretty much what they showed in Kaggle. So that should now complete our different types of loops, the for loop and the while loop. Any questions on loops or when you might want to use which one to choose and things like that?
Yeah, feel free to post your questions on chat. I think Chuba had a question, what's the difference between range and X range? I don't know if we covered X range.
Yeah, I haven't covered X range. That's maybe, yeah, that's a longer discussion, but it's a good question. We could probably cover that. If someone wants to briefly answer it, I have to always look that up.
There's some that are ported from Python 2 to Python 3, right? And there were some
changes in the behavior.
Changes in behavior, yeah.
Yeah. I almost exclusively use range when I'm working with big data. So let's go on to something that's very unique to Python and very popular, a very popular feature, and that's called list comprehension. And it's all based on the properties of the list that we've been going through. But as an example, I'm going to demonstrate it this way. Let's say we have a task that we're giving a list of numbers, and we want to get the squares of all the numbers and put that into another list for us. So the typical approach we might think of is to use a for loop, which we just talked about before. We'd make our empty list. We'd go through our numbers, which is, we already know what those are up here. And we're going to append the square of them, number times number, right, to our list and print that out. So, we can do that, get some big numbers. That's our squares. But another approach for this is to write it in a very shorthand way, which is using list comprehension. And in this case, we're just going to do without the for loop, and it's basically built in here. We're going to do the square of this n, which we're going to say comes from the n in numbers, which is our number in numbers in a sense. So this is a shorthand way of writing basically what's above. And you can see we've got it in brackets because it's going to result in a list. And if we run this, we'll get the same answers as before, but we've only written it in one line. So this is known as list comprehension. Give you some more examples. Let's take our task that we were given that same list of numbers. And I only want to get squares, which are less than 2,000 from them. So these was our result before. We had a 6,000, a 5,000 something, 3,000. So we had some that were over 2,000 and some that were below 2,000. So I want to only pull out the values that are less than 2,000. So using list comprehension, I can write just as I did before, except for now I'm going to add a conditional if on the end, which is that our squared is less than 2,000. A lot of people like to think of this as, if you're familiar with SQL, as a where clause. So you're selecting this in a certain table of numbers, right, where the value itself is less than 2,000. So that, if you're familiar with SQL, that might be an easier way to think about it. I find just understanding what an if is pretty straightforward in list comprehension. But let's run that and see what we get. So here it did what we exacted. It picked out the ones that are less than 2,000. What about if we want to write a function where we're returning the number of squares in the list of numbers that are greater than 1,000. Again, now I'm going to say this is called, this method, as George talked about defining functions. I'm going to pass in the list of numbers, and I'm going to directly return this list comprehension, but I'm going to actually take the length of the values. So I think I had, well, we'll see. I think it's going to be 7, right? That's, I have it as in for, because I had 10 total. 3 of them were less than 2,000. I think there's 7 of them greater than 1,000. So I'm doing this all in one line in my return statement, and there's my answer when I call it with our numbers. How would I have done this without list comprehension? So here I redefine that function again using my for loops and my if statements, and I have to track the value and count it as I go, and I'm going to return that count. So this is kind of a very drawn out way of doing it, and it gets the same result. It does it in 6 lines versus 1 line. So that's the power of list comprehension. You can do extremely advanced things all in one statement, one line. George mentioned this a little bit, that, you know, I think they mentioned in the Kaggle that always choose readability over simplicity. So if your list comprehension gets to be so hard to read and figure out what's going on, it's probably better to at least unroll some of it into your for loop or an if statement, something that's more readable. I don't know if we mentioned it, but Python is a interpreted language, and the interpreter does the bit of turning all these human readable language into the bits that run on the GPU or CPU, right? And hopefully, I always hope, you know, that if I write it in list comprehension, or if I have to write some of it out in more detail with more lines to make it a little more understandable, that the interpreter actually produces the same bits in the back end. And of course, you know, I could run some performance and, you know, run thousands of numbers through here and compare the timings to see if that's actually true. But you would hope the interpreter is smart enough to do that. I think you're not going to see that much of a performance hit by writing it out when you need to, when called for. List comprehension I highly recommend using when it's understandable and clear what you're doing. But if it gets so obtuse that no one can really figure out what's going on, just write it out. That's just my advice. They didn't really go through this, but I wanted to just show you some more things with lists and some of these things. So again, we talked about range of numbers. I'm going to take the output from range and cast it as a list. Oh, sorry. So here you can see it got a list from 0 to 1, which is what you would expect. But what happens when I do this with a string? And the reason I'm doing this, I wanted to show you what a list, when you cast a string to a list, what it gets. Anybody have any guesses what the output's going to be? Be brave. It could be an error, right? All right, I won't hold you in suspense much longer. So what it does with a string, when you cast a list, maybe unexpected to a lot of people from using different languages, but it actually takes every character within that string and puts it into a list of strings, character strings. So just a fun little thing that they didn't talk about, I think, but maybe they did actually, I think. So let's talk about a little bit about the list operations, just a little more, and the performance, in other words, the speed of how these things perform. Often in you know, in machine learning or deep learning, we're using very, very large lists. And I just wanted to go through some of the performance aspects of that. And I'm going to talk in terms of big O notation. If you're not familiar with that, I have a link here to the wiki page where they go through it. But hopefully my English will be plain enough. So for operations like indexing, where you're just pulling one value out based on the index, and assignment based on index, which I showed, the order is a constant value. So it doesn't change depending on So you're only doing this one time with one value, and it's a constant value. We talked about appending, where you're adding entries to a list. That again is just a order one, which is a constant. I will throw out that it's considered to be amortized, because what it does behind the scenes is the first time you call append, it actually creates a new memory space that's 3 times the size of the list you have. And then appends after that are actually immediate. They don't cost, there's no more memory allocation. And so that's why it's considered an order, a constant value. The first one's painful, but then it gets averaged over all the rest of the calls to append until you fill it up past 3 times the original amount. Pop, which is a very useful thing, it actually removes the last item in the list. That again, when you're moving just the last item at the end is constant value. But if you're going and removing a value internal to the list, not at the end, that becomes an order, an O(n), which means it's basically dependent on the size. So as n is the size of your list, the bigger n gets, this is going to scale with this and cost more to do it. The same thing with inserting, where you're putting it anywhere in there. It's going to be, the larger n is, it's order n. The deletion operator, we didn't go through that too much. We did a lot with iteration. We're going through the list, one item at a time. That depends on the size n. Contains is very similar, like in like a for loop. Contains is another way. You have to look within at each item in the list. So that again is order n. Getting a slice is kind of depends on the slice size. So here K is going to be that slice size. We've got some more order ns. Reverse is a neat thing. It just is kind of intuitively, all it does is take the last item and put it at the front, and then reverse all the items after that. So you're reversing the whole order of the list. That again is order n. Concatenate, which is where we talked about using the addition operator, the plus between 2 lists. Depends on the size of the new list that you're adding. So if you have 2 lists, A and B, this operation is going to depend, performance-wise, is going to depend on the size of that B, that second list. How big is it? And then sorting, which puts all the items in the list in an order, is an n log n, very expensive operation. So that's going to be very slow. And then multiplying is also going to be very slow. It's going to depend on the size of both lists that you're multiplying. So you've got the n and k in there. Anyway, that's kind of, I just wanted to throw those out there as a nice little way of looking at the efficiency of lists. We will hopefully in later sections talk about different kinds of collections that you can use from other libraries that are much more efficient than just raw Python lists. That's all I have. Anybody have any questions? Sorry, I didn't understand.
Questions, feel free to unmute yourself or type your question in the chat. Jana, I think you had a question.
Yeah, David, I was just wondering your thoughts on list comprehension versus using like a map function with Lambda. Do you have preference there? What are your trade-offs when you're deciding between those?
Sorry, say it again. I heard about the map function, the trade-offs, but I didn't hear the first part.
Just wondering what your preference or thoughts are about list comprehension versus map functions.
Good question. So I'm usually using map functions with much more complex data structures. For instance, like tf.data sets and things like that. So I don't have a comparison. I haven't used maps with the lists very much. So unfortunately, I can't give you a good answer.
I think, Liana, they are both vectorized. So both the list comprehension and map are vectorized. So they're much faster than the loops. but I think they use the same mechanism under the hood. Must be the same order of performance.
And I use lambdas extensively when I use Pandas, which is a library hopefully we'll get to see later. I think it makes much more sense if I think of something in operation I want to do at one row, and then you can call that function, the lambda function, on the entire Pandas data series or data frame, and it will operate that. It will do that operation on row by row level. I think Robert posted a link online. Maybe we can take a look at that offline as well.
I think maybe list comprehension is a lazy evaluation. I think I saw it somewhere, but maybe I'm wrong.
Could be, yeah. This reminds me of another session that's going on. Yeah. Could be that it's evaluated only when you actually use it or print it out. It's a good point.
Could be.
I had questions for you, if you don't mind, David. One is, you had a multiplication in the end, and you said it's O of n of k. Are you multiplying two lists with each other, or is that O of n of k?
Multiply, yeah, it's two lists, so it should be defined up here. No, sorry, it's not here.
So if they have different lengths, how?
But it's two, yeah.
Is that defined for like a specific case, or like, let's say I have a list with 10 items, another list with 3 items. Does it make sense, or?
I'd have to go into the actual definition, it'll help multiply and see. But the order in K tends to me to indicate that you're doing each one, yeah.
Yeah, that's what it looks like. And the other one is, you predicted that you're going to have 7 numbers greater than 1,000. Did you hard code your random state or something on your random generator?
I did not.
I'm surprised it got
I didn't. Did I seed? I might have seeded it. Hold on.
That's what I wanted.
No, I didn't. No. So I got lucky.
That's what I was about to say. How did you know they're going to be 7 more than 1,000?
Yeah, that's a good point.
Cool.
No, I just got lucky.
Any more questions for David? Cool. Oh, if you don't mind, stop sharing, David. Dimitri, I think you're next. Thank you for going on your own path there, David, and making your notebook.
Can you see my screen?
Yes.
Yeah. So it's unit 6 of this series, and this is about strings and dictionaries, both very important data types in Python. So strings can represent pretty much any length, from single character to millions of characters in a single string. Like a very long document can still be the same data type. And Python is very rich in terms of the instruments and methods to work with strings. And so this Kaggle page covers some of them. I wish I had a systematic notebook just as David had, but I'll try to mention some of the methods that might be important. So strings can be, in Python, can be enclosed in single quotes and double quotes. There is no difference absolutely between X and Y. These are the same objects. And it's important to be able to use both, because sometimes you have sentences like this, which do use single quotes. And by the way, this is single quote, not an apostrophe. This is a different ASCII symbol. And when you do have a single quote, you have to use the double quotes at the ends, because otherwise the interpreter will get confused and will not understand where the strings begin and end. And vice versa. If you have double quotes inside, you would use single quotes at the end. That's how it gets confused. So there is a very handy special character, backslash, in Python strings that lets you do many things that would otherwise be difficult. So it lets you first. It lets you interpret some of the symbols in a special way. Like if you want to do a string with a new line character or a tab, that's when you would use the backslash. So like here, a backslash n or a backslash t or backslash r carries return. So it will interpret Python will interpret that as exactly that. So it wouldn't interpret this as the letter n, but would interpret as a new line. But also conversely, if you want to use the quotes or some other special symbols literally, you could use backslash to represent them as like literally what you want to type in, as opposed to some functional character. So this is called escape character, and there's a whole section, there's a whole description of how they're used. Yeah, so this is again the escape character. A very important or a very useful thing is triple quotes. You could represent the strings with triple quotes. Most of the time when you would use them is in all kinds of help descriptions and help strings inside classes or inside functions. So when you need to include multi-string description of some code, you would typically use triple quotes. Yeah, so this is also again on the quoting. As David said, strings are sequences and they're easily converted into lists and into tuples if you need to. But strings are immutable, as opposed to, in contrast with lists, you can't change a part of the string. And this is, sometimes people forget that, but it's really important that anytime you do some change to your string, actually a new object is created. So the old object still lives in memory, and then the new object is created. It's because they are structurally similar to lists. They can be indexed and sliced in exactly the same way. And here are some examples of that. They do accept many of the same methods that the list accept. Like you could measure the length by this len operator. And you could do all kinds of looping and list comprehensions over strings, exactly because the interpreter treats them the same way. So this is for every character in planet, and planet is defined as Pluto. Yeah, for every character in this variable planet, take that character and attach this exclamation mark and a white space to that character and form a list. So basically, you could produce this type of thing with the same traditional list comprehension. Yeah, so this is they illustrate that strings are not mutable. You can't change part of the string. Every time you try to assign something, it will produce an error. As I said, many useful methods exist built in Python, and there are quite a lot of all kinds of libraries that work with strings specifically. One of them is called string, like you just literally import string and then you work with that. It's also a wonderful library. But some of the useful functions or some of the useful methods are converting the string to uppercase, lowercase. You could do title case, like only the first letters capitalized. You could do this index produces the occurrence of the first string. So the first occurrence of the string in so in this string, the substring plan occurs at the 11th place. So this is what it outputs. And again, it's important to remember that because strings are immutable any methods or functions you call on strings will produce something. There can be an object, a method that you call, and then it, mutates the object itself. The string gets changed. It will never get changed. Some arbitrary functions starts with, ends with. You could change whether you could check whether the characters in the string are numeric or alphanumeric or just characters. Very useful two methods. They are basically inverse of each other, split and join. Split will take your string and split by some character, by some separator that you specify. If you don't specify anything, it will split it into a list, split it by the white spaces. So basically, the simplest example is just take a sentence and call .split, and will produce a list of words out of that sentence. And then the reverse operation, you could call the .join on a list, and it will produce a single string out of the list. So yeah, this is the splitting of a single sentence into a list. And then yeah, basically they have this original variable date string, and then they split it into year, month, and date by the separator, and then they basically change the format. They join back that list with another separator and get a coherent single string. So again, very useful and quick way to do all kinds of reformatting. Yeah, this is just an interesting example of how you can basically do two things together. So first, you create some list of string objects through a list comprehension, and then you immediately, within the same line, you join those objects, those string objects, into a single long string, using this .join method. Dot format is used all the time. It lets you basically format. Most of the time, you would use that when you want to format a number, and sometimes the variables come, like for example, in a float32 format, and you don't need that. You only need a few decimal places, or you just need a round number, and so you use this dot format. I personally, dot format was very popular in Python 2 and in previous versions. I personally prefer to use the same thing, but in a different syntax. It's called F notation. You basically do F single quote, and then you have the same thing. But they work exactly the same. Basically, let me find some example. Yeah, that's the example. So basically, you have this entire string, this string here, and then you have these places that are denoted by these curly braces, and these are the formatting conventions of Python strings. And then after that string, you mention dot format, and then you have your variables. And what the syntax does is that it casts the variables after the dot format, the arguments to dot format. It casts into these curly braces and formats according to the instructions that you have in the curly braces. A little bit clumsy, and as I said, the F notation seems to be cleaner, and I think it's introduced in Python 3. So there are a lot more functions. You could basically replace parts of the strings, find substrings, etc. And I think the Python, the original Python pages have a lot more on that. So dictionaries is another serial sort of structure that are widely used in Python. And basically what it does, it presents a correspondence between two sets of objects. Ones are called keys and the others are variables, values. So key value pairs are what, forms the dictionaries. And, this is a very typical example, like keys as strings and values as numbers. So the keys must be unique. You can't have, the same keys twice. And keys themselves they come from a set, which is another data type in Python that, only has non-repeating values. And values can be anything, like any object can be value, including, very complex objects. Like you could have a dictionary mapping some, strings to TensorFlow models, for example, or something, equally complex. You refer to specific values by using the square brackets. So this is retrieving the element within the dictionary numbers that has the key 1, and it happens to have the value 1. So that's how it works. There is, yeah. So just as we had the list comprehension, we could have dictionary comprehension. It works pretty much the same way, except the element for something if something. So the element, instead of just being a single value, the element is key value pair, key value correspondence, and then the syntax is basically the same as for lists. I don't remember if they cover that, but one thing, if the dictionary numbers had the key 1, it will produce something meaningful. But if it didn't have the key 1 and you try to retrieve, if you try to retrieve the key that does not exist in the dictionary, it will get you an error. And so you would, in those cases, you would need to use the get method. So dictionary.get, and then the key that you're trying to retrieve. If there is no key, if there is no such key in the dictionary, it will return some default value that you'll also specify. So let's see what's next. Oh yeah, so basically that's all they have. Yeah, and I don't see the get value method here, but it's really really useful sometimes, because it's not always you don't have to remember at all points in your algorithm, which keys exist or don't exist in the dictionary. And so this get method is used instead of just instead of retrieving like that, you would do .get in the key. But I think I would stop here, George. So please go ahead if there are any questions on dictionary source strings.
Yeah, there were some questions on the chat. So David, you're saying that lists you can have repeated values, but in dictionaries you only have unique keys. So that's one difference between lists and dictionaries. Let's see what else. I know that towards the end, this notebook has items or get items method that's usually allows you to iterate both over the keys and the values of a dictionary.
Yes, yeah. So the keys, values, and items, the pairs, all of them can be addressed like this. Dig.keys, dig.values, and dig.items returns both keys and values. Yeah.
Awesome. Any questions for Dimitri and strings and dictionaries?
I just have a comment. One thing that would have been really helpful for me when I was starting to learn Python would have been to focus more attention on really becoming comfortable with the difference between mutable and immutable types.
Right.
That would have saved me a lot of headaches when I was first starting with the language. knowing how they're treated differently, where the immutable types are usable as keys for hash functions, knowing what those are useful for, knowing what the mutable types are useful for, and especially how they get passed around to functions. For instance, mutable variables are passed by reference essentially to functions, which can lead to some really surprising behavior if you're just getting started coding in this language. I mean, I was coming over from that lab and found it very frustrating at first.
It's
Yeah,
not
I
just
agree
this
absolutely.
language.
Yeah.
It's not just this language. Anything where you can have call by reference means that you can have a function change your data structures out from under you and get, shall we say, unusual results.
Right. So just like one example of that is that if you define a function, you're allowed to put default arguments on the function definition line, where you can pass a parameter named variable X and give it a default value. You pretty much never, I mean, if I use the word never, there's always going to be an exception to it. But the basic rule that I learned was that you never want to put mutable values in as your default arguments, because what happens is that the function gets defined once when it first reads that function definition, and then that same list object might get reused multiple times, and you might call the function multiple times in your code and think that you're getting an empty list every time, and you're not. so yeah, I would have definitely I would have advised myself going back again to really become more comfortable with mutable versus immutable.
Yeah. I've been a C programmer since the 80s, and that kind of thing is the source of all kinds of hard to find bugs.
Yeah.
Cool. Any more questions? For those of you who are on the chat, I created a poll number 1. If you don't mind just opening your chat window and voting for it, that'd be great. We could use your feedback for our next session. We're asking you, do you prefer we take a little bit of a deeper dive on the theory tutorial side? We do a 50-50 split on tutorials and exercises, or do we focus more on exercises? So take a look on the chat and we'll take your feedback into account and plan accordingly for our next session. Cool. Let's cover the last session and then we'll open another poll number 2 later on. Let me share my screen. Thank you, Dimitri. That was very useful. The last module, or the last module for this course is working with external libraries. And the whole point of coding is to write something that you can reuse. Reusable code is one of the key features that allows you to build more and more complex algorithms and tackle more interesting problems. So the whole point of this module here is to see how can you use the default libraries that Python has, or how can you use libraries that other people have built? How do you install them? How do you import them on your program? And how can you take advantage of them? So in Python, you import new modules using the keyword imports. That could be a built-in module that comes with Python out of the box. Like, for example, math, it's a module that comes with Python. You have to import it for you to use it, and you can call all its methods. So math, for example, if you look at the type of it, it's a module. It's not an int, it's not a float, it's not a string, it's not a dictionary. It's a module. So module, think of it as a collection of variables here that somebody else created, and another team of developers. If you want to see what is under the hood of math, you can do the dir math, or the directory of math. And you can see that it has so many other functions. Some of them are attributes, some of them are functions here. So for example, pi is an attribute, power is probably the power function, sinusoids, functions, tan h, and all that. So using the format function that Dimitri mentioned, you can specify the math of pi. You can see with 4 digits or 4 decimal places, or 3 decimal places, or 4 significant digits, what is the value of it. There are other functions you can call in math, like log. And again, if you remember the help function, you can take a look at it and can give you a short description. And also documentation is very helpful. If you Google Python math log, it will probably take you to the documentation for math module. If a module is pretty lengthy and you don't want to mention that all the time, you can create an alias for it. And you do that using the as keyword. So you're importing math as empty. And then wherever you use math, you just use the empty keyword. That's the same as importing math and assigning math to a new variable called empty. Things get complicated, or before we go there, you can import all the modules and all the classes and all the attributes from math by doing a star. Basically, you're saying from the math module, import every attribute and every function. That way you don't have to do math.py, you can just do py, and Python will reference that, will try to figure out what is the module that has py defined and figure out that it's math. Same with log, log is now defined in math. This import star, if you come from a Kaggle calls this like a purist, like a Pythonic world, it's not a good idea because let's say you do something like this, where you import every module or every function from math, you import everything from NumPy as well. If you do py, actually the issue is with log, you'll get an error. And that's because log will probably be taken from the last library that you imported, which is NumPy. And in NumPy, you cannot define log with just 2 integers. I think they take it takes a list as an input. Yeah, an array type. So a good idea is to either import them explicitly, like from math, import explicitly the modules that you need or the classes that you need, or make sure that you use aliases. So import math as something, and then when you call log, make sure you use that alias of the math.log. A module can have submodules. So for example, NumPy is a module, a very popular module in scientific computing in Python. If you look at the type of NumPy.random, you'd think it would be a class or a function or an attribute, but it's a module itself. So basically you have a submodule, what is called. Then if you want to look at the first 15 attributes of NumPy.random, you can see it has its own classes, its own functions, its own attributes, and so forth. So if I want to create a list of 10 random integers from 1 to 6, I do that by importing NumPy. Then after that, I would call NumPy.random, which is the submodule. That one has a function called randint, random integer, with its own arguments. And yeah, this is just some examples here that all the different modules like Matplotlib, Pandas have their own objects, have their own classes, have their own operators, have their own functions, have their own attributes, and it's really interesting to check them out. And if you're not sure what kind of object you're looking at, if you type, it will give you the object in Python. And if you're not sure what is under the hood of a module or of a class or a function, you can do the dir role, into dir and the name of the module. Cool. And help is there for documentation as well. Another thing that is critical is something called operator overloading. So by operator, we've seen, plus, minus, division, addition, power, and so forth. We would think that this would mean something to us, but Python is very specific. And if you try to do a list plus an integer, you're going to get an error that says that you cannot concatenate a list to an integer. You need to be both lists. Another thing is roles, I think, is an NumPy array. So in NumPy array, the plus operator allows you to do a NumPy array with an integer, but Python list by default doesn't allow that. So that's something to keep in mind. Yeah, you can cast things as array, and you can do the same operation as before. the elements, so NumPy have their own syntax, so you can get, so in this case, X is a list here. You can get the second sublist, and you can get the last element, which is 6. But if you try to do that for X list, this will not work. I'm trying to understand what was the issue here.
I think you'd have to actually do a bracket 1 and then a separate bracket -1 on X list, right? It's a nested list, and the difference is that NumPy allows you to index them just by putting a comma in between them rather than 2 separate.
Got it. This comma. Yep, I didn't see that comma. Look at that. Yeah, so the difference is the comma. Got it. Yep.
So you could still index X lists 1 -1, but you'd have to write it, you know, bracket 1 end bracket and then start bracket -1.
Got it. You have to break it out. Got it. Yep. So it's the syntax. Thank you, Robert. Yeah, you'd think if you use plus, that thing would make more sense, but as we'll see in other libraries, for example, TensorFlow, the popular machine learning and deep learning framework, you can define what is called a TensorFlow constant 1, and another one A, another one B. You can add them up, but if you try to look at the type, you're actually going to get a tensor type. You're not going to get a number 2. And if you look at the TensorFlow documentation, that you'll see that this is a symbolic handle. Basically, it contains information on how things will be stored in Python once your what is called graph is executed, or once your program runs. But as of now, it's just a tensor, basically a collection of data. It doesn't contain a specific value. Yeah, and speaking of other modules, another popular one is Pandas. It has a very popular data structure called data frame, which is basically a table. And if you're familiar with SQL, you can do things like, so my data frame usually is called df. It contains a column called population. So in that data frame, give me only the records that are that have population more than 1 million, and that's what it means in Pandas, and the continent is South America. So you can do that with just one line using Pandas. Yeah, I just quickly want to see if there's anything special in the coding exercise. There was an interesting session here. Let me see if I can quickly run it. There was something on slots, I think, where somebody was, there's an exercise when you trying to plot what is the return when you're trying to pull a slot in a casino game, and every now and then you get this huge payout of $200, but it costs you $1 to run, and then you'd see this graph. And then I think it just asks you to become familiar with setting titles and labels and format of the x-axis and y-axis and so forth. And looking at what is under the hood for the graph, or what other functions can you call. Another one, this was a little bit interesting. There's a race, you have this input as a list, and I think you have to use an approach where you have to find basically, so this is a Mario Kart game, and you have to find which special item gave you the most victories. For example, Peach here used all the special powers and she finished 3rd. Bowser used this item and finished 1st. So I think the goal here was to figure out which is the item that gives you most wins, I think. Let me see. Yep, blackjack as well. That was interesting. I try to code this, but then later I figure out a bug of what happens in blackjack when you have the issue of aces, where you have to make sure that you can use it as a value 1 or 11, as long as it doesn't exceed the value of 21. So you just have to take care of those use cases there. That's it on external libraries. Let me go back all the way to the beginning. Yeah, if you have any questions about external libraries, let us know. If you have any questions about any other module, let us know. I will quickly look at the poll, and I'll open up for another poll in the meantime as well. Cool, so we got some more feedback on the poll. Okay, let me post another poll then, or actually verbally ask it. Let me share my screen.
I had a general question
Okay, go for it.
on naming conventions for functions in Python. It seems to use the underscore space rather than camel casing. Is that correct?
For variable names?
No, for function names.
Yeah. I usually use underscore and lowercase everywhere, but there's something called PEP8. Sorry, I should have mentioned that, which is basically a Python programming code, style code on how you should name your variables, how you should name your functions. So that's interesting. Let me post it on our chat as well. If I can find the chat. There it is. I didn't want to take a deeper dive at PEP8, but think of it as like best practice on how to you do indentation, maximum line length, blank lines, imports. So let's see, there's one on variable names or naming conventions. So principal, naming styles.
See down there, function, variable names.
Yeah, let's go that. Function names should be lowercase with words separated by underscores and necessary to improve readability. Okay. Variable names follow the same convention. Mixed case, I'm not sure what is mixed case, is allowed only in context when there's already the prevailing style to retain backwards compatibility. I guess if you have maybe older versions of your code, I'm not sure what that mixed case would be. But this is a good styling guide. And if you've never seen it before, if you're starting Python now, this is a good start to go over this first. It's basically a best practice of how you should name things and how you should code.
And some of the IDEs will let you use, they will alert you when you're violating PEP, right? So no, I don't know how to do that with any Jupyter notebooks, but you can definitely do it with the IDEs.
Yeah. Cool. Okay, then I have one more poll for you, friends. So that was lesson number 1, Python. There's about 14, 15 more. There's one on introduction to machine learning, intermediate machine learning. There's one on data visualization, Pandas, feature engineering, deep learning, SQL, geospatial analysis. I'm not sure what this micro challenges is. Oh, this is like a actual coding exercise, airline price optimization. Machine learning explainability, natural language processing, AI and reinforcement learning, and data cleaning. So I'd like to open it for a poll if you don't mind. So option 1 is we choose and pick some specific items that we like, maybe like machine learning and deep learning. Option 2 is we quickly go over all of them. Maybe we try to cover not everything in detail like we did today, but maybe we just skim through all these different sections, but we go through all of them. And option 3 is, I don't know if anybody else recommends another option, but we either pick and choose and we go in a little bit more detail, or we go through all of them, but we skim through them simply because there's so many of them.
Maybe pick and choose.
Yeah, so option 1, you can choose. Option 2. Oh. datasets. All right, let's vote now. You can type 1 or 2. Okay, while you're voting, let's see what else we have. I think that's about it. Another thing, maybe I can spend a little bit of time on the Kaggle itself. So if you go under your profile, the good thing is as you're doing these exercises, you're building your notebooks, and I highly encourage you to also check out the forums. And you can also check your activity here in like similar to GitHub of what's going on every day. You can put a picture or description. And as you do more and more notebooks, I haven't spent much time on Kaggle, as you can see, but as you do more and more notebooks, as you spend more time in discussions, or as you upload your own data sets, or as you compete in competitions, these numbers will go up and up and up. And that's where you get some more visibility, especially if you're looking for a new career, a new role. Think of this as like your hands-on GitHub account.
And I'll throw out there the data sets are extensive, so you got free access to a lot of data sets to play with. The other thing is the notebooks, or the kernels, as you used to call them, notebooks, I guess now. They have CPU, GPU, TPU versions of these. Just like Collab, it's all free. They limit, for instance, how many hours you can run the TPU per week and things like that, because they don't want people doing production work here. But yeah, you have access to very powerful machines.
Got it. And if you want to look at, you can also upvote notebooks, or you can fork other people's notebooks, and you can extend them if you want. And if you see now, there's some very popular notebooks going on here on other competition, or maybe a popular data set. And speaking of competition, if you go under compete, you'll see the current either open or completed or special competitions. Now we have, I don't know if Ted has joined us from the San Diego group, but they're actually going through this motion prediction for autonomous vehicles competition this weekend. Just throwing that out there in case that's something interesting to you. Or if you're into medical healthcare, there's another competition here I think there's a competition for anything you might find interesting, I think. And if it's not a competition, maybe it's a data set. So let's say you're into airlines and you want to somewhere with airline, you can just search for it. There's a sentiment analysis from Twitter on US airlines, passenger satisfaction, delay, cancellations, you name it. If you remember some of our coding challenges, we actually took data from here, from Kaggle. Cool. I'll stop sharing here. Yep, thank you for voting for poll number 2. I see a lot of options for pick and choose here. Okay. Pick and choose is, I think, makes more sense simply because there's so many lessons that we can cover. With that said, the next few ones I will definitely going to do is definitely the machine learning, the introduction to machine learning and the advanced machine learning. So if you're joining us on Python, please go ahead and cover the next one, the introduction to machine learning, and after that we'll do the advanced one. And after that, we're probably going to regroup and figure out what to do next. With that said, thank you for joining us. If you have any questions, comment, feedbacks, let us know. We also have a Slack channel for you to join us if you want. I will stop recording here. And if you're new, thank you again for coming. And I hope to see you next week. Have a good evening, everyone.